learn the formula. Hybridization is half into, this is valence electron which is present in the central atom, number of singly bonded side atoms or number of singly bonded atoms to the central atom, plus anionic charge. Anions are negatively charged ion, so anionic charge, and minus cationic charge. So cations are positively charged. So cations get the charge by giving the electrons, so it is considered to be a positively charged ion. So the number of electrons must be deducted here, and anions are accepting the electrons, so definitely anions must get the electron, so I have to add the number of electrons here. So now we will proceed how to find the hybridization by using this formula. Simply if I take s orbital, the basic orbital s orbital, I will consider the count of the orbital as 1, and s and p orbital I am mixing one s orbital and one p orbital, so I am having two orbitals here, s and two p orbitals, so that is sp2, and s and three p orbitals I am mixing and get sp3 hybridization, and the number of orbitals are 4. And here next to p orbital I have completed p orbital, and next to p orbitals I will give the correct explanation, and next to p orbital I am mixing one d orbital. So the total number of orbitals considered here will be 5, and taking one more d orbital is sp2, sp3 d2 hybridization. So the number of orbitals are 6, sp3 d3 hybridization, the number of orbitals are 7. You just take this count. Okay, here this is a single orbital, so it is not considered to be a hybridized orbital. One s orbital and p orbital will merge and it will give sp hybridization. The hybrid orbitals are 2, sp2 hybridized orbitals it's 3, sp3 hybridized orbital it is 4, sp3d it is 5, sp3d2 it is 6, sp3d3 it is 7. Now consider all these numbers. So what value you are getting in this calculation of hybridization? What value you are getting in this hybridization calculation? You just use the respective value to determine what is the respective hybridization. We will prove this with an example. I am considering methane. Methane molecule. The formula for methane is CH4. I will just not consider this number of electron of hydrogen. I will consider the valence electron which is present in carbon. The valence electron with respect to carbon is 2s2 and 2p2. The electronic configuration is 1s2, 2s2 and 2p2 for carbon. So the valence electrons are 4. So here applying this formula, half into valence electrons are 4. Number of side atoms, we are having singly bonded hydrogen, 4 hydrogens plus 4. Is there any anionic charge? No. Is there any cationic charge? No. So simply I will add 0 and subtract 0, or I will not consider the values. So half into 8. The hybridization will be half into 8 will be 4. So the respective hybridization for 4 is sp3. So this is the hybridization of methane. Sir, what if I get load pairs in the central atom? I will give example for that also. Okay. Now we will check the hybridization of water molecule. H2O, oxygen, the electronic configuration is 1s2, 2s2 and 2p4. So number of valence electron present in oxygen is 6. So using this formula, I consider half into valence electron plus number of side atoms. Valence electrons are 6. Number of side atoms present in water is 2. And anionic and cationic charges are not there. I will leave it as it is. So 1 by 2 will be 8. So the hybridization value here is 4. So with respect to 4, we are having sp3 hybridization. So the hybridization of water molecule is sp3 hybridization, and the structure 3-dimensionally, it is tetrahedral in nature with the 2 lone pairs. It's tetrahedral in nature with respect to 2 lone pairs. Now we will move on to some chargeable species. We will check the hybridization formula whether it is working for some chargeable species. I will consider ammonium ion, NH4 plus ion. So here the nitrogen, the electronic configuration is 1s2, 2s2 and 2p3. The final valence electron present in nitrogen is 5. So considering this, half into number of valence electrons are 5 and number of side atoms present here is 4. Anionic charge is not there, but we are having one cationic charge. This cationic charge can be reduced here. So minus 1. So equal to half into 1 by 9. Minus 1. It's equal to 8 by 2, that is 4. The hybridization value is 4. Similarly, as like water molecule, the hybridization here is also sp3 hybridization. So, if suppose I am having a compound IF7, this the d orbitals are also equal. How to identify this IF7? The number of valence electron present in iodine is 7, and number of 7 fluorines are attached to that, so number of side atoms are also 7. Now applying this formula, half into valence electron is 7 for iodine and number of side atoms are 7. No cationic or anionic charge, so I will close. So like 14. So here we are having the hybridization value is 7. So what will be the respective hybridization? It is sp3 d3 hybridization. sp3 d3 hybridization.